Alright, so I want to do a quick video here, separate out talking about antimatter here. It goes along with some other stuff. I've mentioned it in other videos. We talked about neutrinos and antineutrinos when we talked about the beta decay in a previous video. I talked about that, but I never really explained what is antimatter, what are antiparticles. Basically, it turns out that for every kind of particle that we have here in this table, there is another particle called its antiparticle that's exactly the same in every way except its charge is negative. And you could basically rewrite a new table just like this one here, but put a bar over top of each letter, each symbol, to indicate that it's the antiparticle, and then just do the opposite charge for them. Any of the negative charges become positive, any positive charges become negative. So for example, the up quark, you could put a U, put a bar over it, and instead of a charge of 2/3, it would be a minus 2/3, and then everything else would be the same. 2.4 MeV for the mass, 1/2 spin, and it would be the anti-up quark. Okay, and you could just do that for the whole table. Bar, change the sign on the charge, and you have this. Now this was predicted before these were long ever found, but it turns out it all worked the same. In fact, we could take all of these particles, do all of the antiparticles for them, and rebuild all the same stuff. You can make atoms and molecules out of anti-electrons and anti-protons. Anti-electrons we called positrons before. You could do all the same sort of thing. Now there's a few things that go along with this. One, anytime antimatter comes in contact with its regular matter counterpart, they annihilate. They turn totally into energy, and it's just an explosion. And this is sometimes thought of as a way that we have so much empty space between matter, is that at the beginning there was both antimatter and matter, and there was just slightly bit more matter, and they're all just annihilated, and we're left over with just a tiny bit of regular matter. We don't find this antimatter a lot often, just created naturally, but we can. I mean, it does in beta decay, but mostly any of this we make is made in the laboratory. Now, one of the big ways this is thought of is that antimatter is actually backwards time traveling regular matter. So where you would have, like, say, an electron traveling one way in time, going like this, the antimatter proton would be just that electron or an electron traveling backwards in time. So it'd be this like a little E plus. It'd be a positively charged. The positron would be it going backwards in time. So if like this was our time axis or something. That's basically what it would be. And when we get to drawing Feynman diagrams, hopefully that'll make a little bit more sense, because there's a way you draw antiparticles in those. A great example of this, talking about the electrons, is the one electron universe hypothesis or theory. Basically, the idea was that there's only one electron in the entire universe, and so this axis would be our time, and this could be position. And so the idea is, it's all the electrons we think we see is just one electron actually traveling forwards and backwards all crazily through time. And if you go to any current moment, like say this is the present time right here, and you go all the way across, up here it would act right here where you looked and saw it on the present line right there, it would look like an electron because it's going forward in time, and over here it's going forward in time, so it would look like a different electron even though it's the same electron. And again, here electron, and here electron. But on the downward sloping ones, you would see that as a positron. And so here it looks like a positron, and here it looks like a positron, and here it looks like a positron. On the downward sloping side when it's going backwards through time. But this idea is that, there really was just, or is just one single electron moving forward and backwards in time and making it appear like there's a whole bunch of different electrons everywhere. The major problem with this idea, of course, is that if this were true, there would be the same number of positrons as electrons. But as it turns out, there seems to be a lot more electrons than there do positrons. Well, anyway, that's all I really wanted to say about that, and we'll continue on in a future video.